Now we go to question 5. It say like this, the question 5, it say you have a line of charge, so it means a wire, a long wire, very long wire, at a distance d from a very long, essentially infinity, uniform line of charge. The electric field strength is 1000 Newton per coulomb. At what distance from the line will the field strength will be 2000? So to do this problem is quite easy. You remember that the electrical field produced by a line of charge, by a line of charge, a uniform line of charge, will have lambda ddq divided by ddl, or ddq divided by ddy if you imagine the x is y. So the electrical field produced have this expression. I have shown you in this in the video. This is the electrical field produced by a line of charge. Also, we have proved this same result using Gauss' law. We have constructed a cylinder around the charge. We have applied Gauss' law, and we have solved for Gauss' law, and we have found that the symmetry say that the electrical field should be this value. So this x is the direction of the vector. The direction of the vector is going from the, if this is positive, well, it doesn't matter. The direction is going from the cable, perpendicular to the cable, to the point where I want to measure the electrical field. So it say, the problem is say that the electrical field is 1000 Newton per coulomb, and the electrical field is at distance d. At the distance d is lambda divided by 2 pi epsilon 0 divided by d, and this is 1000. So we know the distance d, so from the distance d we know lambda. So lambda is the density of charge of the cable. The cable have this density of charge, 1000. So at the end I have the lambda. This is the value of lambda. I suppose I have, well, I don't have the d, but this is the value of lambda. Lambda will be 2 pi epsilon 0 multiplied by E multiplied by D. This is the lambda, okay? This is the lambda. So now I have, what is the electrical field when this is 2000? Okay, when this is 2000, the electrical field will have the same value. So we will have a new x, a new position, a new distance from the charge. A new distance x from the charge will be an electrical field. Of course, the distance, if it's a stronger electrical field, the distance will be lower distance dx. So I will use the same expression for the electrical field. So I will plug in my lambda. I will plug 2 pi epsilon 0. This will be 2000. And from this equation, I will find the x. So the x will be like this. So the x will be d divided by 2. Okay, so 2000 was, okay, d divided by 2. So you decrease, the electrical field is decreasing to double of the value. When you increase the electrical field to double of the value, the distance is decreased. So you increase the electrical field to double of the value, and the distance decreased to half. This is only happening in this kind of electrical field that the dependence with the distance is x, is not x squared. In a normal electrical field produced by a point charge, this is not happening at all, and we have seen many, many times. So the problem is solved, and I hope you can understand this question.